When we design a warehouse, we always have to deal with two fundamental resources, space and time. Though space, of course, refers to the ground floor of the warehouse, to the storage opportunities that are created by using shelves and rack, etc. And on the other hand, the time refers to the requirements of picking items from the shelves or loading items into the shelves. And time, you can always, or you can set time equal to labor costs, because these operations are performed by humans. So if we save time, we more or less automatically save on labor cost. In this diagram, you see real-world data for 25,000 different items, SKUs. So on the x-axis, you see how many picks per item have happened in the last months. This is data for 1 month. Though the farther to the right an item is placed, the more popular this item is, because we have more requests, we have more picks to do for this item. And on the y-axis, you have the flow of the items, and the flow is measured in physical volume. Though if we request one item that is very large, this creates some physical flow. And when we request on the other hand, small items, but we request this many more times, then the physical flow might be similar of both products. Okay. So what you see from this picture is that there is very little correlation between popular products or unpopular products and products that are have a very high flow or a very low flow. So therefore, designing the layout of a warehouse is very difficult, because we have to deal with all these different combinations. This will become more clearer on the next graphic. So here again we have the same 25,000 SKUs as on the previous picture. And here the SKUs are sorted, are ranked according to their popularity. So those SKUs that have the highest popularity are placed to the left side, and when we go further to the right side, we sort the SKUs with less or almost no popularity. And what can you see? What is the interpretation of this graphic? You see that a very small portion of the SKUs stored in our warehouse, on this graphic maybe 15% roughly, is responsible for the majority of the picks. This is like the Pareto rule or 80-20 rule. 20% of the items are responsible for 80% of the work. This rule applies in this example as well. So a small number of SKUs are responsible for a high number of picks, and a high number of SKUs have almost no picks. Nevertheless, of course, we need to store these SKUs in case our customer requires them. And what you can imagine, if we have popular SKUs, then the process design is rather straightforward. We know we will have to deal with these SKUs every day. We can predict the demand for these SKUs. On the other hand, for the unpopular SKUs, we do not know if we have to deal with them every day. Maybe the average demand for such a SKU is very low, 2 items on average per year. Think, for example, of a warehouse designed for maintenance equipment of drilling equipment of an oil field, and the things are stored to replace defect drilling equipment. And then we know maybe on average we have a demand of 1 per year, but we have no idea when this demand actually will happen. And if the standard deviation is high, then maybe in 1 year we need 3 items, in another year we need 0 items. So in order to cover this demand, we have to use a high safety stock, and we need a lot of space to put all these items in our inventory. So this is what makes designing a warehouse challenging. We have popular items on the one hand that have a low physical flow and a high physical flow. And on the other hand, we have unpopular items, items that we do with a low number of picks. And for these items, again, we can have a high flow or a low flow. And designing a layout for such a warehouse is very challenging. To sum this up, we can say that each warehouse is, in a certain sense, 2 different warehouses. So the first warehouse is organized around the very popular SKUs, and this warehouse requires a lot of labor. The second warehouse is organized around the unpopular SKUs, and for these we require a lot of space. Okay, remember, each warehouse is in a sense 2 warehouses.